Welcome to the Calm Cosmic. It's wonderful to have you here tonight. Tonight, we're going to explore some of the strangest, most counterintuitive facts about black holes, and I promise, despite involving gravity, time, and the occasional existential crisis, they're far gentler than they sound. Let's begin with a thought. The universe is a surprisingly quiet storyteller. When it wants to teach us something, it doesn't shout or flash or send obvious clues. Instead, it whispers through starlight, tugs delicately at gravity, and occasionally drops a hint in the form of something so strange that it forces us to stop and blink twice. Black holes are one of those hints. A black hole begins its life not as a monster, but as a star that has run out of fuel and slowly collapses under its own weight. A tired sun, curling in on itself, folding inward like a weary traveller settling into a chair. It's almost poetic in a slightly dramatic way. When the collapse becomes too intense, too heavy, space itself gives way, buckling into a pit of gravity so deep that not even light escapes. And once light can't escape, it leaves behind a perfectly still, perfectly silent region of the universe, a black hole. Despite what sci-fi movies tell us, black holes aren't roaming the galaxy like hungry cosmic sharks. They don't chase things. They don't suck anything in. They just sit, quietly, calmly. Gravity, after all, has no sense of urgency. If our sun were magically replaced by a black hole of the same mass, which to be clear is very unlikely unless it suddenly becomes very dramatic, Earth would continue orbiting just fine. No spiraling, no doom, just business as usual. Perhaps slightly darker business, but still quite stable. That's the thing about black holes. Their drama comes from stillness, not chaos. Their power comes from silence, not action. And maybe that's the first calming truth about them. The universe's most extreme objects are content simply to exist. If you could approach one, not that you should, unless you packed a very sturdy spacesuit and an even sturdier sense of adventure, you would notice something very strange. As you drift closer, space itself begins to stretch. Time slows down, your clocks tick lazily, and the light around you curves inward, as if it's trying to peek into the darkness ahead. This boundary, the famous event horizon, is the ultimate you can go in, but you can't come out doorway. But we'll talk more about that in the next part. For now, imagine it as a serene shoreline where the sea of gravity becomes too deep to swim back from. A quiet, cosmic edge. Approaching a black hole isn't chaotic. It's surprisingly peaceful. There's no swirling tunnel, no spiraling descent unless the black hole is actively feeding, which for most of them is rare. Many black holes drift through space like sleeping giants, undisturbed, invisible unless a star wanders too close. And speaking of drifting, here's a strangely soothing thought. If you fell into a black hole, hypothetically, gently, with cosmic permission, nothing noticeable would happen at the horizon. No sudden rip, no alarm bell. You'd simply float across it as if nothing changed, all while the rest of the universe watched your clock slow to a crawl. To them, you would appear frozen forever at the edge, a tiny cosmic statue outside of time. To you, everything would continue smoothly. It's strangely comforting in a way, a reminder that perspective shapes reality. From the outside you're frozen, from the inside you're drifting. One moment, two truths, a very quantum sort of peace. But even stranger is the fact that black holes are not bottomless pits. They're not infinite monsters. In fact, they're temporary. Slowly, patiently, they evaporate. They shrink. They give energy back to the universe through a quiet glow called Hawking radiation, a soft whisper of heat leaking from the edges of darkness. Think of it as a cosmic exhale, a long, slow unwinding of gravity's tightest knot. We'll talk about that glow in its own part too. And as the universe ages, black holes will be among the last things left. When all the stars have gone out, all galaxies have faded, and everything is quiet, black holes will still be there, silent watchers of a universe going to sleep, and eventually, even they will fade into darkness. It's a strangely beautiful ending. Not dramatic, not violent, just quiet. For tonight, let your mind rest on the idea that the universe's most powerful objects are not violent storms, but still patient wells of gravity. Perfectly calm, perfectly silent, perfectly content to sit in the dark. And in that darkness, there is peace. Take a breath. Let your thoughts slow. The universe is vast, but it is gentle, and we're only just beginning. Tonight, we're standing at one of the strangest borders in the universe. A border with no line, no fence, no sign that says turn back now, and yet, it is one of the most profound boundaries ever discovered. The event horizon. It sounds dramatic, almost theatrical, like the title of a sci-fi thriller, but in truth, it's one of the calmest, quietest places imaginable. A cosmic shoreline where the rules of the universe gently shift beneath your feet. Imagine drifting in space. There is darkness all around, but not the threatening kind, more like a soft blanket pulled over the universe. Ahead of you is the black hole, but at this distance, it doesn't look menacing. It's just dark. A patch of sky where nothing shines, perfectly still. If outer space had a resting face, this would be it. As you float closer, nothing rushes toward you. There's no wind, no sound, no dramatic pull. The gravity increases, yes, but gently, steadily, like the pressure of a warm hand guiding you forward. It's not a cliff, it's a slope. A very deep one, yes, but that only adds to its quiet charm. And then, without knowing it, you cross the line. You don't feel it. There's no bump, no jolt, no cosmic security alarm. The event horizon is not a wall. It's simply the point beyond which even light cannot escape. But light doesn't scream as it falls in. Time doesn't shiver. Reality doesn't flicker. Everything continues smoothly. From your perspective, the perspective of someone crossing that invisible boundary, absolutely nothing unusual happens. It's almost disappointing, in a funny way. You expect something groundbreaking, something dramatic. But the universe often hides its biggest revelations in silence. Now, for anyone watching you from a safe distance, things look completely different. To them, you slow down, and slow down, and slow down. Your motions stretch out like thick honey poured onto a table, and just as you reach the event horizon, you appear to freeze altogether. You never fall in, not in their timeline. From the outside, you become a permanent ornament on the edge of the black hole, forever suspended at the border, a tiny, motionless, cosmic figurine, the universe's least exciting museum exhibit. Of course, you know better. Inside your own timeline, you're still moving, still drifting forward. Time remains obedient, at least for you. It's the universe outside that seems to hesitate, unsure whether to let you go. This difference in perspective, this gentle disagreement between realities, is part of what makes black holes so strangely calming. They remind us that truth is layered, that sometimes nothing is absolute, that where you stand determines what you see. Even the horizon itself is peaceful, not a violent trap, not a swirling drain, just a quiet threshold where escape becomes impossible, the point where light, the fastest thing in existence, finally gives up and says, "All right, fine, you win," and sinks inward. But there is something beautiful about this surrender. Light doesn't disappear abruptly. It stretches, softens, reddens, and fades until it slips from view, like a sunset stretched over infinity. Scientists call this gravitational redshift, but you don't need the name to appreciate the poetry of it. The closer light gets to the event horizon, the longer its wavelengths become, until the light that began its journey bright and energetic becomes a calm, deep, fading whisper of itself. It's almost meditative. Even time behaves differently here. From the outside, your clock slows until it practically stops. From your point of view, the universe ahead of you appears to be running faster. Stars speed up. Galaxies swirl by in fast motion. Millions of years pass in moments. It sounds dramatic, but the way it unfolds is strangely graceful. No shaking, no ripping, no cinematic distortion. Just the universe quietly fast-forwarding, like someone gently turning the pages of time. And here's a thought that may surprise you. The event horizon is not the most extreme part of a black hole. It's simply the edge, the frontier. Inside, things get more complicated, but not necessarily more chaotic, at least not right away. We'll save spaghettification for the next part, but even that begins with a slow, gentle pull. For now, let's linger a moment at the horizon. If you could pause here, floating just above the line where light hesitates, you'd see something extraordinary. Not because the black hole is doing something dramatic, but precisely because it isn't. Black holes don't have surfaces. No crust, no solid shell, no glowing sphere. They're as smooth as gravity can make them. Featureless, perfectly round, perfectly silent. A sphere of pure nothingness wrapped in the most intense stillness in the universe. In a strange way, it's comforting. No storms. No eruptions. No sound. Just an object so powerful it doesn't need to do anything at all. Astronomers have even captured images of event horizons. Not the hole itself, but the ring of glowing gas and light swirling around it. Even these images, blurry as they are, have a softness to them, like a cosmic donut dipped in shadow. Standing at the edge of a black hole, you're reminded of something subtle. Silence can be powerful. Stillness can be profound. And boundaries, even the scary ones, can be crossed without fear. If the universe's most dramatic threshold is this calm, then perhaps our own transitions, the endings, the beginnings, the unknowns, are gentler than they appear. Tonight, the universe has saved one of its most peculiar secrets for you. A secret wrapped in a word that sounds like something you'd order at a small Italian restaurant. Spaghettification. Yes, that's the real scientific term. You'd think physicists of all people would choose something more elegant, something more serious. But no. When faced with the extreme stretching effects near a black hole, they took one look and said, "Well, that looks like spaghetti." And the name stuck. Permanently. But don't worry. Despite how dramatic it sounds, we're going to approach this idea gently, slowly, and without any alarming images. Think of this not as horror physics, but as cosmic yoga. A very slow, very exaggerated stretch, guided by the universe's most patient instructor, gravity. When you drift closer to a black hole, gravity pulls on you more strongly at your feet than at your head. It's a difference so small at first you'd never notice. The pull is gentle, almost comforting, like someone softly tugging at the blanket covering you. Only as you move deeper toward the black hole does this difference grow. More pull at the bottom, slightly less at the top. Your body elongates very, very gradually. And honestly, at the start, it probably feels nice. Think of a long stretch after waking up from a nap. That satisfying lengthening from fingers to toes. That quiet release in your muscles. That's the early stage, the safe stage, the relaxing stage. Of course, eventually the stretching becomes extreme, but you won't feel it suddenly. It's a smooth gradient, a slow transition. The black hole doesn't yank or jerk or twist. It simply pulls, consistently, patiently, with the calm persistence of something that has all the time in the universe, because it literally does. But before this gets too alarming, let me share something comforting. Not all black holes spaghettify you at the same point. Small black holes, the kind found when stars collapse, have such strong gravity right at the horizon that the stretching begins early, long before you cross the event horizon. But supermassive black holes, the kind in the centers of galaxies, the ones millions or billions of times more massive than our sun, their event horizons are so immense, their curves so wide and gentle, that you could cross the boundary without feeling any stretching at all, not even a tickle. You'd pass through the event horizon of a supermassive black hole the same way you'd walk through warm air. No drama whatsoever. So spaghettification, despite its terrifying reputation, is not a guaranteed cosmic punishment. It's simply the universe applying gravity unevenly, the same way Earth's tides tug on the oceans. The only difference is scale, and perhaps the menu-inspired name. What's calming, strangely enough, is that the universe doesn't rush it. Gravity increases smoothly, predictably, with no surprises. The closer you drift, the deeper the gravitational well becomes, pulling you gently forward. It's like sliding down the world's softest, longest ramp. But there's another side to this stretching, one less talked about, and one that brings its own quiet charm, the stretching of time. As you approach the black hole, time itself begins to lengthen. For you, everything still feels normal, but for anyone watching, your movements appear to slow. Your fall seems to take longer. Minutes become hours. Hours become centuries. And then, eventually, an eternity. This slowing has an unexpected calming effect. It's as if the universe is saying, take your time. There's no rush. Even your final moments, from the outside perspective, are stretched into infinity, a cosmic reminder that sometimes the end is not abrupt, but infinitely patient. There's also something strangely beautiful about the very idea of spaghettification. In a universe where so much happens chaotically, stars exploding, galaxies colliding, this process is smooth, continuous, and mathematical. A perfect gradient, a clean curve, a transformation that follows the rules completely, with no sudden breaks. The word may sound chaotic, but the process is anything but. In fact, this stretching effect is directly connected to one of the strangest mathematical ideas in physics, geodesics, the paths that objects naturally follow in curved space-time. Near a black hole, these paths become steep, like trails leading down into a deep valley. Everything that enters, from dust to light to unlucky astronauts, simply follows the path nature laid out, smoothly, predictably, almost peacefully. So if the concept still feels intimidating, imagine it like this. You're a ribbon, floating gently downward in a soft cosmic breeze. You lengthen, not because something tears you apart, but because space itself is stretching beneath you. You're not fighting gravity. You're not resisting. You're simply going where space-time is leading you. And maybe, just maybe, there's something serene about letting go of control in a place where control doesn't matter. Of course, spaghettification does eventually become fatal. There's no avoiding that. But remember, we're talking about an extreme environment billions of light years away, one you will never accidentally stumble into unless you've taken a very wrong turn at the galactic roundabout. And more importantly, we are here not for the danger, but for the wonder. For the fact that the universe contains processes so strange, so surreal, that the best comparison we have is a bowl of long, thin pasta. For the fact that physics can be poetic, that gravity can dance, that space can stretch, that time can flow unevenly, like syrup drifting down an invisible spoon. For the fact that in the deepest, darkest corners of the cosmos, beauty still exists, even in the form of a cosmic noodle. Take a deep breath. Let the universe feel big but gentle, because in our next journey together, we'll step back from the stretching and move into something unexpectedly soft, unexpectedly elegant, and unexpectedly hopeful. We're going to explore how black holes slowly fade, how they glow, how they whisper heat into the cold universe, how they evaporate not in fury, but in a long, slow, peaceful sigh. If you're still here with me tonight, drifting softly through this quiet universe, welcome back. Take a moment to feel where your body is resting. The bed, the couch, the pillow beneath your cheek. Let the weight of your limbs sink a little deeper. Let your breath fall into a slow rhythm. The cosmos is patient, and there is no need to hurry. We've crossed the horizon, stretched gently through space-time, And now we're ready to meet one of the most surprising truths about black holes. They glow. I know. The words black hole and glow don't usually belong in the same sentence. It sounds like saying a shadow gives off light or silence makes a sound. And yet, in one of the most beautiful twists in the history of physics, black holes, the universe's darkest objects, emit a faint, delicate, almost ghostly warmth. Hawking radiation. It's not dramatic. It's not fiery. It's more like the quiet heat your hands feel when hovering just above a mug of tea. Soft, subtle, nearly invisible, but real. The story begins not at the center of the black hole, but around its edges, in the thin veil of space-time wrapped around the event horizon. Up close, space-time isn't smooth. It's not a perfect fabric. Even in complete darkness, it vibrates with tiny fluctuations, little flickers of energy that pop into existence and disappear again. Quantum physics tells us that the vacuum, the emptiest emptiness you can imagine, is never truly empty. It's always buzzing, trembling, humming with possibility. Tiny pairs of particles bubble into existence for the briefest moment. One particle, one antiparticle. Opposites, twins, dancing together. And just as quickly as they appear, they collide and vanish, returning their borrowed energy to the universe. It's like the fabric of existence is breathing, the smallest inhale and exhale imaginable. Now near a black hole's event horizon, something unusual happens. When one of these little particle pairs appears right at the boundary, the black hole's gravity can pull one in before it reunites with its partner. One falls inward, the other remains outside. Separated, incomplete, suddenly, what should have vanished instead becomes real, and that lone surviving particle, the one that escapes, becomes Hawking radiation. This process isn't violent. It's not chaotic. It's quiet, delicate, a whisper of heat slipping away from the edge of darkness. Black holes don't roar as they lose mass. They don't sizzle or crackle. They simply leak, gently. Some physicists describe it like steam rising from a cup on a cold morning. Others imagine it as the black hole very slowly, very patiently exhaling, letting go, softening, releasing its grip on the universe one tiny particle at a time. Even if you stood right next to a black hole, very close but somehow still alive and ignoring the whole spaghettification issue, you wouldn't feel the warmth, not even a tickle. Most black holes are far too massive, far too cold, radiating far less heat than the cosmic background around them. It's only the tiny black holes, the ones we haven't yet found, that would emit anything noticeable. The bigger the black hole, the quieter its glow. Imagine that. The most massive objects in the universe fade the most silently. And here is the thought that makes Hawking radiation so calming. Black holes, once thought eternal, are not permanent after all. They're not cosmic garbage disposals endlessly consuming everything. They don't grow forever. They don't live forever. They age. They soften. They sigh. They shrink. Very, very slowly. Slower than anything else we know. For a black hole the mass of our sun, the process would take 10 Earth-burn years. That's a 1 with 67 zeros. A number so huge it makes the entire age of the universe look like a coffee break. Your calendar app would not appreciate the reminder. As the black hole gets smaller, it radiates faster. It glows a little more brightly. Not bright, not like a flame or a star, but like an ember that warms as it weakens. Eventually, in the final moments of its life, the black hole lets out a last burst of energy. But those moments are so far in the future, and so gentle compared to the unimaginable timescales before them, that thinking about it can feel strangely peaceful. In the quiet end of the universe, when the stars have dimmed, when galaxies have dispersed, when everything is cold and sparse, black holes will still be there, the last glowing bodies in a fading cosmos. And then, one by one, they too will dissolve into the dark, not with a bang, not with a flare, but with the quietest whisper physics has ever predicted. It's comforting, in its own way, to realize that even the universe's most powerful objects have a life cycle. They are born from dying stars. They rest in stillness for unimaginable ages, and then, slowly, softly, gracefully, they fade, not through destruction, but through release. Black holes are often portrayed as cosmic monsters, devourers of light, destroyers of worlds. But the truth is far gentler. They are patient. They are passive. They are surprisingly elegant, and in their final act, they give energy back to the universe. Light returned from darkness. It makes you wonder, if even black holes let go eventually, then maybe the things we hold tightly, stress, worry, fear, can be released too, slowly, gently, in our own time. Take a breath. Let it out. Feel the way your chest softens. That's your Hawking radiation, a tiny exhale to the universe. You've travelled far, across horizons, through stretching space-time, past whispering particles, and now the cosmos has one last surprise for you. A surprise that doesn't sparkle or shine, but sings, or rather, chirps. Take a slow breath. Let the air settle in your chest. Because the idea that black holes make sound feels impossible. Space, after all, is silent. There's no air, no medium for vibrations. If you shout into the void does not shout back. It simply keeps your secret. And yet, in 2015, after a century of predictions and hope and quiet scientific patience, we finally heard two black holes collide. Not with ears. Human ears could never pick up such a delicate event, but through the rhythmic stretching of space-time itself, a faint ripple that washed through our planet after a journey of more than 1 billion years. Imagine that, a signal starting long before humans walked on Earth, travelling silently across galaxies, passing through nebulae, threading between stars, crossing oceans of darkness, all so that one day, at the right moment, with the right instruments, we could hear the universe say, chirp. That's really what it sounded like. A soft rising whoop, a tiny cosmic drop of water plinking into the ocean of space-time. The instrument that caught it was LIGO, a pair of enormous detectors shaped like giant, silent L's stretching 4 kilometers in 2 directions. Their only job was to listen for the faintest changes in distance, changes thousands of times smaller than a single atom, changes so tiny that the passing gravitational wave nudged the instruments in and out like a slow, sleepy heartbeat. And LIGO recorded it, a tiny wiggle, a gentle ripple, a chirp, 2 black holes, one about 36 times the mass of our sun, the other about 29, spiraled into one another in the emptiest darkness imaginable. For billions of years, they orbited each other quietly, slowly drawing closer, their dance tightening, their pull deepening. They were silent partners in a cosmic ballet, moving in perfect gravity-driven grace. And then, in the final fraction of a second, they collided. Not explosively, not like a star or a supernova, but in a smooth inward plunge, the way 2 raindrops merged together on a window pane. Their shapes blended, their horizons joined, their masses fused into one deeper, calmer well of gravity. The energy released, 3 entire suns' worth, came out not as light, but as ripples in space-time, gentle waves that stretched and squeezed the fabric of the universe. They spread outward like ripples in a pond, crossing the cosmos effortlessly, quietly, steadily. No flash, no fire, just the universe adjusting itself. What LIGO caught wasn't the sound of air vibrating, it was the sound of space-time breathing. And what's even more soothing is how simple the signal was. No complications, no noise, just a rising tone that lasted less than a second. A tiny whoop. If the universe had a notification sound, that would be it. Scientists converted that stretch into audio frequencies, and listening to it is strangely comforting. It's peaceful, innocent almost, gentle. And behind that softness hides an unimaginable event. Two black holes merging in perfect silence, in perfect darkness. It's a reminder that the universe is not always loud when it does something extraordinary. Sometimes its grandest acts are whispers. Close your eyes for a moment and imagine what that collision looked like. Not in violent cinematic detail, but softly. Two dark circles, invisible against an invisible background, spiraling toward each other in slow, shrinking orbits. Gravity pulling them together like two magnets drawn across a black table. Their motion smooth, their union quiet, their aftermath simple, a single larger black hole resting, settling into its new shape, ripples fading outward like fading echoes, silence returning. There's something deeply calming in that image. The universe is full of chaos, exploding stars, drifting asteroids, flickering quasars, yet the black hole merger is more like a deep exhale, a cosmic sigh, a release of tension. And this tiny chirp, this faint wave that brushed Earth so gently, opened a new window for us. We no longer look at the universe only through light. We can now listen to it, hear it groan and whisper and ring, hear space-time vibrate when the cosmos changes shape. We've begun hearing the universe dream, and as we end this journey tonight, there is one final soothing thought to rest on. Black holes, despite their reputation, teach us more about peace than about destruction. They show us that silence holds power, that stillness contains depth, that boundaries can be crossed gently, that endings unfold slowly, that even darkness can glow, and that even the quietest events can echo across the universe. You are drifting now through the calmest parts of existence, through gravity's softest notes, through space-time's most delicate curves, through cosmic truths that feel less like facts and more like lullabies. Let your breath slow, let your thoughts quiet. Let the universe cradle you in its vast darkness. Because in this darkness there is no danger, only depth, only quiet, only the soft hum of a universe that has been unfolding for billions of years and will continue unfolding long after we sleep. Thank you for being here tonight, for exploring these wonders with me, and wherever you are, under a blanket, in a dim room, on a peaceful ride home, I hope the universe feels a little less overwhelming now, a little softer, a little gentler. You're part of it, after all, made of the same stardust, shaped by the same laws, drifting through the same quiet cosmic sea. And now, as the last ripples of tonight's story fade, let yourself rest, let yourself breathe, let yourself drift into the deep, peaceful sleep waiting at the edge of your own event horizon, the place where the day finally lets you go. Good night, from the calm cosmic. Sleep softly among the stars,